All right, so here's the idea of an empty set. An empty set is probably what you would expect. It's a set that contains no elements. And we use this symbol, this circle with a line through it. Okay, that represents the empty set. So that's what we use to represent the empty set. And the empty set is a subset of every set. Okay, it contains no elements. So even though it contains no elements, every one of those non-elements is an element of the other set. So of another set, of any other set. Okay, so that's just something to remember. It's a little bit confusing, I know, but technically the empty set is a subset of every set. All right, so I want to work through this example because this is going to come in handy when we're working with probabilities. Okay, I know it's just going to seem a little weird at first, but it's actually this is something we need to know how to do. List all the subsets of a given set. Okay, so no matter what, you should always start with this type of question. Always start with the empty set because the empty set is a subset of every set. Okay, remember that. So your first subset should be the empty set. Okay, now I can also create a set that just has one element in it, right? So A, that set, with curly brackets around it, it makes it a set. The set that contains A is a subset of this capital A set that's defined in this problem, okay? And really all of the single element sets would be subsets of this set capital A, okay? So these are all the single element sets that are subsets of the set we're dealing with here. Now we could take any two sets as well, any two elements and put them in a set, and they would also be a subset. So A comma B, all right? A comma B would be a subset of this capital A set. All right, we could choose A and C, all right, any two elements. Put any two elements from our set that we're concerned with and put them together in a new set, and they create a new set that is a subset of A. Okay, so now we have the empty set. We have all the one element sets that are subsets of this capital A set. We have all the two element sets that are subsets, and the only thing left that we need is the three element sets, which is basically A, B, and C. Okay, and that's the set that's equal to but that is a subset. So this set A, B, C is a subset of this capital A set. Okay, and again, the order doesn't matter, so they don't have to list out BCA and CAB and CAB and B. I don't know. You don't have to list them all out in order because we only need because the order doesn't matter in a set. Okay, so that's it. We just go through and list all the one element sets that are subsets, all the two element sets that are subsets, all the three element sets that are subsets. If it was a four element set, we'd have to list more than this. But that's it. Go through all the different size sets, and then you've got it.